Okay, so we will continue our discussion about methods for integration. So I believe we the last discussion was all about the shared database. So now we'll be talking about remote procedure calls. I've already taught you how to create objects using Java, and I believe we'll also discuss procedures or methods, no, within an object. So we started to create classes or class to create object, and within our predefined objects using class, we have a lot of fields and functions we could include during the process. So when we define a class, when we define an object, we started with a class, we put some fields which are variables and procedures or methods such as functions. So that's how we make up an object. And we can also link other classes, to form complete objects. So that's how things work when dealing with objects. So I've already shared to you that in in this already shared to you that another way, a mechanism or object or in order that a function can be available on another resources, so we need to we need to no? In this mechanism there has been a need for an object. So in order for the procedure or function to be available on another application or another system, so it needs an object to populate from one system to another. And if the object is populated, so it's easier for the other resources to trigger or call the procedure. It's because of the object representation. No? Because of the object representation. So in this part of our discussion, we will talk about remote procedure calls. So from the word itself, remote. So we will remote something. No? What do we need to remote? It's the procedure, and it's procedure calls or function call. Now it's easier to remote when there is object available on another location or system. So in this manner, there's been a need for skeleton and stub. So in the application B, suppose that the resource is or the procedures are being made up or being made in the application B in a part. So in order for the resource or object having fields and function to be available on another application, there's been a need for skeleton. Uh, Someone, a technology or an algorithm, a technique where we can populate, no, object on another system. That is why we need skeleton. So, and then we also need a stub. So both stub and skeleton are the ones who will be exchange buffers or signals. So when some functions are triggered, the stub will tell the skeleton. So that's the idea. And then when that particular process uh, finishes or ends, so the skeleton will inform the stub, returning a result. Stub are just to in simpler terms, stub are just proxy proxy of the proxy of the skeleton on another, no, on another system or location. So mura bag kuan ba kanang giato man gipopulate ang mga object, no, sa other system. Ang stub murag kuan na siya, mura siya proxy ni application B. Murabag as if the application B is actually within the application A. So that's the idea. Is the proxy now of the application B. So whenever the application B calls a function, you can think of that particular function is in the application A but not. So that's the idea. So as if application B is part of the entire process or part of the entire system of the application A. Okay, so let's read the description. It applies the principle of encapsulation to integrating application. So nanon mo idea about encapsulation, no? So in the idea of encapsulation, the properties, fields, and functionality of a particular field or a particular domain is being encapsulated. Um, the idea is all of those things, the fields and the behaviors or the procedures within the particular domain are encapsulated or being protected or being isolated within that particular system. It's encapsulated, no? So when some other system would like to access it, they have to follow certain standards, certain mechanism to access it. So in this manner, we need stub and skeleton. That's the standard. That's the procedure that we need to follow. Okay? So kabalo naman mong idea sa encapsulation, di ba? You have the experience with your OOP subject. I believe it's been discussed in order for a particular object wanted to access or in order for a particular class to access something in another class, he needs to use the public function of another class in order to access the fields of that particular class, the data of that particular class. Okay? So if an application needs some information that is owned by another application, it asks the application directly. So if an application needs modify the data of another, then it does so by making a call to another other application. Each application can maintain the integrity of the data it owns. Thus, encapsulation was derived. Okay, so to protect integrity and especially those sensitive data within a particular application, so it is encapsulated. Okay, luckily we can share, no, somehow those sensitive data into a specific or dedicated system. And in order for that dedicated system or other system would like to access the data, he needs to follow a certain standard of stub and skeleton mechanism. Okay, considering its difficulty and advantage, we need to take a few. So for its difficulty, somehow applications are tightly coupled together, especially during runtime. Yes, because um, actually they are not tightly decoupled. Somehow it is a thing to consider on the integration. Um, somehow they are being coupled together, especially during runtimes because think about it like application A is now dependent on the application B, the functions of the application B. So when application A runs, so some processes would not function if application B is down, okay, or in maintenance. So there are processes of the application B that are in application. There are processes of the application A that are in application B that would not function with that. So that's the difficulty. So you'll have to really consider the um, how to manage those type of those type of systems that are working together to meet user expectation. Most developers are used to procedure calls where RPI or remote procedure invocation fits in nicely. So aware kita ana no in order to well, we're into organization good nga thing in today's generation of developers. We've learned so much how to call a function, how to catch a return value, how to organize our we can also perform method overriding as if uh, there are multiple similar functions name where uh, we can call a specific on it even though their functions are the same name but they differ in parameters. So that's the advantage of implementing an object-oriented programming or programming practices or programming styles. So it's easy to get through firewalls, no, as it can be implemented using any web services. So the REST, and XML no, over HTTP. So yeah, we will not be having a problem in terms of migrating resources or object from one system to another. It can no, get through firewalls. All we have to do is to use a specific technology for it, and then boom, we can then use this particular mechanism. A good example, one example of one technology we could use no, in our succeeding activities is the RMI, no, the Java RMI. It's a technology within Java we can use. It's a remote method invocation technology. Okay, so having that in mind, so let's consider its advantages. Each application can maintain the integrity and can alter the data it owns. So the problem is during runtime, they are tightly coupled, but the overall idea is that they are somehow isolated. They don't rely too much on each other, like in terms of security. Sensitive data are not easily populated on another system. It's because of the encapsulation idea. Whatever you do, oh no, whatever maintenance you do, whatever upgrade you do on a particular system, it would not affect directly on the other systems because you do it on an isolated idea. You do it on that particular system only. So also, it could reduce coupling of each application to encapsulation by eliminating a large shared data structure. Yeah, with the encapsulation idea, you can eliminate the large shared data structure. How you organize the data remains on that particular system. So, um, yeah, we've mentioned already about RMI. So now let's talk about distributed object technology. So we now have the idea that in order for a particular resources like fields and function be populated in another domain or another system, it needs a technology. It needs to share an object, and in order we can do that, we need a technology called distributed object technology because we will share object on another system. So we need object technologies, no distributed object technology. And let's consider first its advantages. No code reuse. When we share a function to uh, another domain, another system, of course, no, that new system asking for the particular function would not rewrite the same function. It would reuse the same function. Okay. Code reutilization makes RAD a reality, empowering programmers to quickly, efficiently develop highly functional applications using existing plug-and-play components. Code reuse is also cost-effective since developers are not required to reinvent the wheel. So the entire wheel anyway for each instance the client server application or new piece of functionality. Pwede ka no, mag method overriding, especially when a particular function is not really that much needed on that system, but others are needed. Code reuse no, diminishes the amount of required system testing since these mature components have previously undergone extensive evaluation and testing. So this is the big idea of code reuse. No? There, whenever makasulod mo mga companies, no, maka encounter mo mga existing na mga system, and that particular system is being used for a long time in that company. So you know that those function available on that systems are really working well, really paid off, no? Really reliable because the functions, no, that system is being used for a long time. So when you create a new one and some of that functionality of the new system is available on that system, so you don't worry, no, you don't take too much time of developing the new systems because there are functionalities existing already on the other system. All you have to do is uh, install a technology, an object distributed technology that you can use so that all of those functions available in the existing system is just pulled, no? Yeah, be migrated on that new system that you had developed. Isolated idea, no? Distributed object systems are broken down into separate, self-contained modules, no, that can be worked on independently of each other, yet are capable of interoperating with other components. But since the methods and functions existing within the modules are isolated, so they may be separately developed to meet system requirements without worrying about ramification on code in other parts of the system. Okay, so other advantage is code maintenance. No, due to the modular design of distributed object application, changing the functionality of application does not require complete application overhaul. Okay, with the majority of distributed object application located on the server, distribution of code to the client is effectively handled by simply swapping the modified components on the server side, so thus eliminating the need for massive updates to all clients. Thin clients. Now, since the major components of distributed object applications are located on the server or on the network of servers, the client-side application can be kept small and lightweight. It allows also thin clients allows more of the client system resource to remain free, while the bulk of application process is performed on the high-end servers. With object distribution across a network of machines, thin client can access an infinite number of data repositories and legacy applications of unlimited size, thus making this space and memory on the client side a non-issue because the actual process remains on that system who's sharing an object. So whenever a client use an application on its side, the actual process happen on the server, not on the client. So that's a good thing. Okay, that's the advantage. Only thin processes are being handled in the client side. That's the idea. So what are the architectures? No, I'm sorry. Java RMI architecture. No. So the technology we could use to share objects is the Java. No, the Java. Java is a technology we could use, and it has a feature we could share object. And because of its architecture available, it's called the RMI. So there's been lists of commonly used distributed object technologies. First is Corba, the Common Object Request Broker Architecture. Get to familiar with this, no? The COM, Distributed Component Object Model, and the Java RMI, the Remote Method Invocation. For the Common Object Request Broker Architecture, Corba, this invocation enables of methods on distributed object residing anywhere on the network, just if they were local objects. You know, as if kung sa stub, no? As if those things are local to that particular system accessing it. A Corba implementation employs object request brokers, the orbs, located on both the client and the server to create manage client-server communication between objects. So there are brokers within between them. So just the idea, like the idea of the stub and skeleton. Arms are the key to Corba distributed object architectures, and they allow objects on the client side to make requests of objects on the server side without any prior knowledge of this object exists, what language they are in, or what the operating system they are running on. So, even though wala kay prior knowledge of those objects nga nag-exist dito siya, no, with Corba technologies, you will know kung sa mga available objects that you could use. Pag, kung pag sa CMD pa, pag type pa ni mo da, dash help dito, mo sure dayon ang mga available tools that you could use. So, mo nga na ang idea, no? When you use this technology, pag type tayo ni mo, pak, mo gawas dayon sa mga available objects. Another thing is we have this distributed component object model. It supports remote objects by running on a protocol called Object Remote Procedure Call. Mo po na iyang protocol. So, para maka-remote ka, the ORPC. It's a proprietary solution and is well suited for the Microsoft-centric environment. So actually, Microsoft is using this, no? The DCOM. The CRM is now heavily used on the Windows platform. Companies like Software, AG provide service implementation through their entire X product for Unix, Linux and mainframe platforms, and Digital for Open VMS platform, and Microsoft for Windows and Solaris platform. So there have been a lot of platforms using this technology. So basically Microsoft products, no? As you can see, whatever you do on the PPT is also be available, no, on the cloud environment. No? What did you edit? What applications? What data of an applications you've been editing? So it would reflect on another application. So applications can talk, no, with this with the distributed technology. So yeah. Also, the COM is best implemented as a solution where the production environment is exclusively oriented around Microsoft products. So that's the idea of the COM. It's highly used by Microsoft. But we can't afford to use this technology, the Corba and the DCOM, because these things aren't available on Java. Um, it needs specialized tools, and it's a proprietary solution, so you'll have to purchase it, and it's very the architecture is very it's very highly required required average skills, no, to manage uh, these architectures are highly proprietary. So let's settle on this last, no, architecture where we can easily understood the object distribution with the remote method invocation. So RMI provides a way for a client and server application to invoke methods across a distributed network of client servers running the Java virtual environment. So as long as we run Java, we can run client and server applications, no, that are um, invoking objects across the network. It's also the fastest and simplest, no, way to implement a distributed. So it's the simplest and fastest way to implement distributed object architecture due to its easy to use native Java model. So long as you're familiar with Java, so therefore it is a good choice for rapid application development types and small size applications that are implemented completely in Java. But there is a main issue, no, with the RMI because it's not that robust compared to Corba or the CRM solution. For example, RMI uses a native transfer protocol, GRMP, which is not currently Corba IAOP compliant. So maglisod in terms of security, in terms of its best practices. So yeah, kulang pa sa RMI. But luckily, we can understood freely, we can understood easily the idea of object distribution because there is a tool available like Java. So this single language crunch make it impossible for RMI to interact with objects not written in Java like legacy applications, no, mga karaan na prevents RMI from playing a more formidable role in large-scale enterprise solution. So dili kay siya yung ana ka um iyang process, iyang features dili kay nga ana ka adaptive no, in terms if there is available legacy applications that are well-rounded or well-used on the industry or dako kay nga company so maglisod ang RMI og adapt tungod ang environment no ng mga large-scale enterprise solutions. Despite the fact that RMI is considered to be lightweight and less powerful than Corba and the COM, RMI still brings to the table some unique features like distributed. Mga nga idea, maka-experience like distributed. Automatic management of objects and ability to pass objects themselves from machine to machine. So takeaways, no, file transfer. So or read this. So you have to post a video and read takeaways or check this presentation will be uploaded in the LMS. And our next discussion will be about messaging. So I'll have to leave it for now. And yeah, enjoy the video. Thanks for watching.